Hey guys, welcome to question MM330 of the Maths Methods 4 to 5 study guide. So, in this question we've got a parabolic bowl which is modelled by the function f of x equals 1 on 8 x squared, where x is between negative 10 and 10, as shown below. All measurements are given in centimetres. Sweet. So we've got this little diagram here, and our first task is to state the width of the opening of the bowl. So this is designed to be a pretty straightforward question. The width of the opening is simply from this point here to this point here. We know that it's from negative 10 to 10, and the distance here is 20 centimetres. So that means that our width is 20 centimetres. That's our first and only mark for that question. So that's designed to be pretty straightforward. Let's just move straight on to part B. Part B is also a 1-mark question. And it says the bowl has vertical supports at x equals negative a and x equals a, holding it steady, where a is a real positive constant. If the length of one of these supports is 4 centimeters, find the exact value of a. Awesome. So we know that the length here is 4 centimeters, which means that our y value at this point on the bowl is 4, right? So when y equals 4, so 4 is equal to 1 on 8 x squared. Just rearranging this, multiply both sides by 8, we get 32 equals x squared. Square root both sides, and we get square root of 32, and then from here we get the 4 root 2. So x is equal to 4 root 2, which means that a equals 4 root 2 centimeters. And that's our first and only mark for that question. That's it. So let's move on to part C. Part C is, again, a 1-mark question and says, water is being poured into the bowl such that the rate of change of height of water in the bowl after t seconds is given by dH dt equals 2 root t, where t is between 0 and b, where h centimeters is the height of the water above the bottom of the bowl. Awesome. How fast is the water rising? 4 seconds after the bowl starts being filled. Sweet. So this is the rate of change of height of water, which is talking exactly about how fast it's rising, okay? So at t equals 4, that's how we can use this formula to find out how fast it's rising, okay? So when t equals 4, 2 root 4, which is 2 times 2, which is 4. Now our units are really important here. So we're talking about rate of change of height with respect to time, which means it's rising at 4 centimeters per second. Awesome. Sweet. So that's it. From here, that's our first mark for this question and our only mark. Let's move on to part D. Now part D asks us to find an expression for h of t. It is a 2-mark question. D, 2 marks. So we need to find h of t, and we know that dH dt is equal to 2 root t, right? So we know that our derivative is this, and we need to find our original, which means we're going to need to integrate this to find that. So, therefore, h of t is equal to the integral of 2 root t dt. Now, I like to change this into index form so that I can actually see what's going on. So, the square root of t is the same as t to the power of a half. So, 2t to the power of a half. Now, to integrate this, all we're going to do is add 1 to this power and then divide by that new power. So, we get 2t to the power of 3 over 2 divided by 3 over 2. Plus c. Don't forget your plus c because we're going to need that when we're figuring out h of t. This is our first mark here. And then rearranging this 2 can come up to the top. So we get 4t to the power of 3 on 2 over 3 plus c. Now we need to figure out what this c is. The question tells us that the bowl is empty to begin with, right? So at t equals 0, the height is 0, right? Because it's empty. So that means that our h is 0 when t equals 0. So 0 equals 4 times 0 to the power of 3 on 2 over 3 plus c. This is 0, so 0 plus c equals 0, therefore c equals 0. Which means that our h of t is equal to 4t to the power of 3 on 2 over 3. And that's it. So that's our second mark there, which is also our final mark, obviously. That's it for part D, guys. Let's move on to part E. Alrighty, part E is a 3-mark question, a little bit trickier. And it says, when t equals 4, find the cross-sectional area of the water represented by the shaded region above. So this little section here. Now, we know that H is equal to, or H of T is equal to 4 T to the power of 3 on 2 over 3. Awesome. And we need to find out the area of this section here. So what do we need to figure out what this area is? Well, we need to figure out the X values at this point and this point, right? Because we're going to need to find the area between these two graphs here. So the only way we're going to be able to do that is by finding our Y value, right? The height of the water. And how do we find our height of the water? Using this formula here. So we know that T is equal to 4, which means that H of 4 is 4 times 4 to the power of 3 on 2 over 3, which gives us 32 on 3. Now you can use a calculator in this question, so that's fine. H of 4 is equal to 32 on 3. And what that means is, when T equals 4, the height of this water is 32 on 3. Right, so our Y value here is 32 over 3. Cool. Now, we need to find our X values at these points, right? Because we need to find out where we're doing the area from. So to find our X value, we know that this is our Y value, which means we can say 32 on 3 is equal to 1 on 8 X squared, right? Because we know that we're dealing with this parabola here. We know that that's the Y value, and we need to find the X value based on that. So from here, we times both sides by 8, and we get 256 on 3 equals X squared. And then X is equal to plus minus the square root of 256 on 3, which equals plus minus 16 root 3 over 3. Now that's our first mark. So we figured out that this point here is positive 16 root 3 on 3, and this point here is negative 16 root 3 on 3. So now what? Well, now we know the endpoints, or the terminals of our area. And there's multiple ways we can do this. We can figure out the area of this entire rectangle and then minus the area under the bottom, and that'll leave this bit here. You could say that this is its own equation and find the area between those two graphs. I'm going to do the rectangle area because I think that's one that most people would kind of think of first to do. So our area is equal to our rectangle minus the area under the graph, right? So this total rectangle here minus this area here. Sweet. So our rectangle is equal to our width times our height, or our length times our width, whatever you want to call it, and minus our integral from a to b of f of x. So our length is this bit here, which is 16 root 3 on 3 from here to here. So we can times that by 2 to get the total length. So that means that we get 2 times 16 root 3 on 3. And our height, or our width, is 32 on 3, right? So times 32 over 3. That's this bit here. Minus the integral from negative 16 root 3 on 3 to 16 root 3 on 3 of 1 on 8 x squared dx. This is our second mark. So figuring out that formula for the area is our second mark. And then we can just evaluate this as normal. So what we get, so this bit here becomes, and again, we can use our calculator. So if you need to do that, please use it. You should. So this bit here turns into 1024 root 3 on 9. And then we can evaluate this into, take away 1 over 24 x cubed from 16 root 3 over 3, negative 16 root 3 over 3. Awesome. Now, this turns out to be 1024 root 3 over 9 minus 1024 root 3 over 27. What this gives us is 2048 root 3 over 27 centimeters squared. That's our third mark. So we found our shaded area, which is this bit here, when t equals 4, to be this. Now that's our third and final mark for part E, guys. Let's move on to part F. Part F tells us that the bowl becomes full to the brim when t equals b. We need to find the exact value of b. Awesome. So we know that the becomes full to the brim at this point here, right? Which is where x is equal to 10. Okay, so when x equals 10, we know that the height of the water is going to be full. The bowl is going to be full. So we're going to need to find out our y value at this point to be able to find our time when that happens. Okay, So we know that our x value is 10. So f of 10 is equal to 1 on 8 times 10 squared, which is equal to 100 on 8, which is 25 on 2, right? So our height is 25 on 2, okay? Which is the same as h of t equals 25 on 2. Awesome. Now this is our first mark, okay? So we've recognized that the height of the water is 25 on 2. We also know that that h of t is equal to 4t to the 3 on 2 over 3, which is equal to 25 on 2. Now we can just rearrange and solve for t. So what we end up getting is 75 on 8 equals t to the 3 on 2. And then from here, t equals 75 to the power of 2 on 3 over 4 seconds, okay? But that's not it, because we need to find our exact value of b, right? So b is when it becomes full, which is this t value, but we just need to state that. So therefore, b equals 75 to the power of 2 on 3 over 4 seconds. That is our second and final mark for part B, for part F, and that wraps up MM330. Guys, if you have any questions, please hit me up in the comments below. But otherwise, thank you for watching, and I will see you in the next video.